Hello friends, welcome back to my channel Knowledge Hub. Let's learn together. I hope you have watched my previous video of cube test. In that video, I have explained the definition, importance and factors affecting the compressive strength of the concrete. So let's begin the second part of the video, which includes procedure, apparatus and results. Now we will see the purpose of cube test in different time lapse. As concrete gains maximum strength in 28 days, since in construction sector great amount of capital is at stake, so there is time concern is there, so everybody wants early results and for to get as early as possible. Instead of checking strength of 28 days, we can check strength in terms of concrete strength at 7 and 14 days to predict the target strength of construction work. From the below table, it is clear that the concrete gains 16% of its strength within 24 hours, whereas 65% of target strength by the time of 7th day of its casting. Till 14 days, concrete shows 90% of the target strength, and thereafter the gain in strength slows down and it takes 28 days to achieve 99% strength. We can judge the strength of concrete until it becomes stable, and we also won't wait for 28 days to judge the concrete whether it is suitable for construction or not. To keep it balanced, concrete is tested at various intervals. Now we will see this in a table as age in days, percentage in strength. First day it achieves 16% strength. 3 days after it achieves 40% strength. After 7 days, it achieves 65% strength. After 14 days, it achieves 90% strength. After 21 days, concrete achieves 94% strength. And after 28 days, concrete achieves 99% strength. The maximum strength gain spike is observed till 14 days. So we test concrete at an intervals of 3 days, 7 days and 14 days. And if concrete fails to result of 90% of its overall strength at 14 days, then that batching is rejected. As you can see, the table explains concrete strength in gain spike. Usually maximum strength gain is observed till 14 days. Now we check these compressive strength at different grades of concrete at 7, 14, 21 and 28 days. These are the grades of concrete, different grades of concrete. This is compressive strength in Newton per millimeter at 3 days. This is compressive strength in Newton per millimeter square at 7 days. This is compressive strength in Newton per millimeter square at 14 days, and this is compressive strength in Newton per millimeter square at 28 days. Now we see for M10, and in 3 days it achieves 4 Newton per millimeter square, while in 7 days it achieves 6.5 Newton per millimeter square, and while in 14 days it achieves 9 Newton per millimeter square in 14 days, and in 28 days it achieves 10 Newton per millimeter square. Similarly for M15, 6 Newton per millimeter square in 3 days, 9.75 Newton per millimeter square in 7 days, 13.5 Newton per millimeter square in 14 days, 15 Newton per millimeter square in 28 days. The same as we discussed, we can see for M20, M25, M30, M35, M40, M45, and M50 grade. This cube test is carried out using 150 concrete cubes on universal testing machine or compressive testing machine. Now is the apparatus which are required. First is this cube mold. Cube mold. It is internal dimension is 150 by 150 by depth 150 mm. It is as per Indian standard 516/1959 compressive testing machine 2000 kilonewton and 15 centimeter by 15 centimeter by 15 centimeter steel cube molds are required, or cylinder having diameter 15 centimeter and length 30 centimeter are used. Now we see the steps of cube test. First is preparing of material for cube test. All the materials must be brought and stored to an approximate temperature of 27 plus or minus 3 degrees Celsius. Cement must be uniformly mixed with a trowel in order there is just no lumps. Mixing of concrete. While mixing of concrete, there are different methods of mixing of concrete. First, machine mixing. Machine mixing, the ingredient must not be rotated. The ingredient must not be rotated for more than 2 minutes, and the following pattern must be followed. Firstly, we add calculator water, then 50% of coarse aggregate, then fine aggregates, then cement, and then balance 50% of coarse aggregate. For hand mixing, the process must be done on rectangular pan until a homogeneous mix is obtained. For dry mixing of fine aggregates and cement, addition of coarse aggregate with the even distribution and addition of calculator water in batch till consistency is achieved. Now casting of specimen. The casting molds are chosen to be made of cast iron and must be cleaned and rubbed with grease on inner side for easy removal of the cubes. The specimen must be cast in 3 layers, as it is 15 cm, 5 cm each, and properly compacted in order to avoid honeycombing formation. Compaction. In compacting through tamping bar, 35 strokes must be done in all parts of the cube for proper compacting. This tamping bar has the dimension of diameter 16 mm diameter bar of length 600 millimeters. Now, age of test. The cube test for compressive strength can be done at 1, 3, 7, 14 and 28 days. In some cases, the strength of greater ages is required, which is performed for 13 to 52 weeks. Number of specimens. It is mandatory to have at least 3 specimens for each day's testing, each intervals testing for different batches. The mean of compressive strength achieved by this specimen is used to determine the actual strength of the batch or concrete. In this sketch, in this picture we can see how the cube molds are casted and how they are removed. Procedure for compressive strength of concrete or cube test. Now next, place the prepared concrete mix in the steel cube mold for casting. Once it sets after 24 hours, remove the concrete cube from the mold. Keep the test specimen submerged underwater for stipulated time. It is for curing purpose. As mentioned, the specimen must be kept in water for 7 or 14 or 28 days, and for every 7 days the water is changed. In this side picture we can see how the cubes are placed in a water tank for curing purpose. Ensure that concrete specimen must be well tried before placing it on the universal testing machine. Weight of samples is noted in order to proceed with testing, and it must not be less than 8.1 kg. Testing specimens are placed in the space between bearing surfaces. Care must be taken to prevent the existence of any loose material or grit on the metal plates of machine or specimen block. Here in this picture we can see this universal testing machine is there. It is the maximum load at which concrete specimen collapse is noted, and this is a concrete specimen. Here the pressure is applied from upper side and from lower side. The concrete cubes are placed on bearing plate and aligned properly with the center of thrust in the testing machine plates. Loading must be applied axially on specimen without any shock and increased at the rate of 140 kg per square centimeter per minute till the specimen collapse. Due to the constant application of the load, the specimen starts cracking at the point and final breakdown of the specimen must be noted. Here we can see the pressure is applied from upper side as well as from lower side, and this specimen must be applied axially specimen load with increased rate of 140 kg per square centimeter per minute till it collapses, and that at what it collapses that reading is noted. Now we see the calculation of cube test. Compressive strength of concrete formula. The compressive strength of specimen can be calculated by dividing maximum load carried by the specimen by cross-sectional area of the specimen cubes. That is, compressive strength of concrete is equal to maximum load carried by the specimen divided by top surface area of the specimen. The surface area of the specimen is 150 mm by 150 mm by 150 mm. It is 22,500 millimeter square. That is 225 cm square, centimeter square. Assume the maximum compression load is 450 kilonewton, as 1 kilonewton is equal to 1000 newton. 450 kilonewton is equal to 4,50,000 newton. Compressive strength of concrete is 4,50,000 newton divided by 22,500 is equal to 20 newton per millimeter square. That is 203 kg per cm square. The same calculation is done for the specimen at different ages as stated below. As we can see the details and specimens. Specimen maximum load that the specimen bear, assume test results in kilonewton. Specimen 1 at 7 days, specimen 2 at 14 days, and specimen 3 at 28 days. That maximum load that specimen bear is 310 kilonewton at 7 days, 408 kilonewton at 14 days, and 445 kilonewton at 28 days. Compressive strength it is 3,10,000 divided by 22,500 is equal to 13.7 newton per millimeter square. 4,08,000 divided by 22,500 is equal to 18.13 newton per millimeter square at 14 days, and 4,48,000 divided by 22,500, that is 19.9 newton per millimeter square at 28 days. As we have assumed M20 grade concrete mix which bears a maximum load of 20 newton per millimeter square. Please note that it is M20 grade concrete is assumed. The minimum strength 65% at 7 days, 90% at 14 days, and 99% at 28 days. Percentage of concrete gain test result 13.7 into 100 divided by 20 is equal to 68.5 is equal to greater than 65% at 7 days. 18.13 into 100 divided by 20 is equal to 90.6, which is greater than 90%. 19.9 into 100 divided by 20 is equal to 99.1, which is greater than 99%. A good concrete should not show less than the minimum compressive strength at respective days. Hence, concrete is safe to use. Now, average compressive strength at 7 days and 28 days is calculated as Newton per millimeter square. Important note. As per Indian Standard 516/1959, minimum 3 specimens should be tested at each selected age. That means 3 specimens at 7 days, 3 specimens at 14 days and 28 days. If strength of any specimen varies by more than 15%, the average strength such specimen should be rejected. So friends, I hope you all have understood the topic completely. If you have any doubts, please feel free to comment. Keep watching my videos and don't forget to share, subscribe my channel. Thank you.